Example number 3. Line L1 has endpoints 1, 2, 7 and 5, 6, 1, while line L2 has endpoints 7, 3, 4 and 3, 9, 10. What you have to find? You have to find the parametric equation of the lines. You have to find the tangent vector of the lines. Also, you have to determine whether the two lines are parallel or perpendicular and whether the two lines are intersecting or not. If yes, then you have to find out the point of intersection. Okay, so this is a numerical which covers all the topics that we have read so far. Okay, so this type of numerical comes in the exam. So let us see how can we solve this type of numerical. Let us first note down the given coordinates. Let us first note down the given coordinates. It is given that the point P1 has coordinates x1 is 1, y1 is 2 and z1 is 7. It is point P1 is 1, 2, 7. Point P2 has coordinates x2 is 5, y2 is 6 and z2 is 1. That is point P2 has coordinates 5, 6, 1. Point P3 has coordinates x3 as 7, y3 as 3 and z3 as 4. That means point P3 has coordinates 7, 3, 4 and point P4 has coordinates x4 is equal to 3, y4 is equal to 9 and z4 is equal to 10. That means point P4 has coordinates 3, 9, 10. Okay. This much is clear in the problem. You have to find out the parametric equation of the lines. So there are two lines, line L1 and line L2. Line L1 has two endpoints, point P1 and P2, and line L2 has two endpoints, point P3 and P4. Okay. So let me show you the figure. Yeah. Yeah. This is the figure. This is line L1 having points P1 and P2, and this is line L2 having points P3 and P4. Okay. Now let us come to a problem. How can we solve this type of equations, this type of problems? Okay. So we have to first find out the parametric equation for line number 1, and then we will find the parametric equation for line number 2. Okay. So let us find out the parametric equation for line number 1. We know that the parametric equation is given by P is equal to P1 plus U into P2 minus P1. Okay. So for line L1, we are finding parametric equation for line L1. That means we are representing here parametric equation for line L1 as P suffix L1. So P L1 is equal to P1 plus U into P2 minus P1. Okay, because we are finding line L1. Okay, so here point P1 is having coordinates 1, 2, 7. So it is written over here in the form of matrix 1, 2, and 7. Plus U is U. Point P2 is 5, 6, 1. So 5, 6, 1. Point P1 is 1, 2, 7. So we have to find out P2 minus P1. That means x2 minus x1 is 5 minus 1. Y2 minus y1 is 6 minus 2. Z2 minus z1 is 1 minus 7. Okay. So let us solve it. We have obtained here P L1 is equal to matrix vertical matrix 1, 2, 7 plus U into vertical matrix x1 is 4, x2 minus x1 is 4, and y2 minus y1 is 4, z2 minus z1 is minus 6. So this is the matrix in the form of vertical matrix. So we can write this matrix in the form of horizontal matrix also. So for writing that, let us convert this vertical matrix into horizontal matrix. P L1 is equal to horizontal matrix 1, 2, 7. It is 7 here. It is long printed here, 7 here. Over the transpose plus U into matrix horizontal matrix 4, 4 minus 6 over the transpose. where the value of u ranges from 0 to 1 always. Okay, so this is a parametric equation of line L1. Now let us find the parametric equation of line number L2. Yeah, listen. So the parametric equation of line L2 is given by PL2 is equal to P3 plus V into P4 minus P3, because we have already used U variable in for line number 1, so that is why we are using here V as line variable for line number 2. Okay, P3 has coordinate, point P3 has coordinates 7, 3 and 4, and point P4 has coordinates 3, 9, 10. Okay, so the P4 minus P3 will become 3 minus 7, 9 minus 3, and 10 minus 4. In this case, similarly, as earlier we have found for line number L1, so the parametric equation for line number L2 is vertical matrix of 7, 3, 4 plus V into vertical matrix minus 4, 6 and 6. Where the value of U ranges from 0 to 1 always. This vertical matrix we can also represent in the form of horizontal matrix by just putting a transpose over a horizontal matrix. So let us write in the form of horizontal matrix PL2 parametric equation for line number 2 is equal to horizontal matrix 7, 3, 4 over transpose plus variable P into horizontal matrix minus 4, 6, 6 over transpose, where the value of V is from 0 to 1 always. Okay. You can find out this problem. You can know the two lines is given. That means here this is line number L1, which is having point number P1 and point number P2. And this is line number L2, which is having point number P3 and point number P4. Okay. From this diagram, it is clear that two lines are there. One line has two endpoints, another line also has two endpoints. Okay. So for these two lines, we have determined the parametric equation. Okay. Now, what we have to find? We have to find out the tangent vectors of a line. So tangent vector is, वेट करेंगे मैं आ रहा हूँ. Yeah, let's continue. Okay. The tangent vector of a line is given by P dash, which is equal to P2 minus P1. So when we are finding, we have to find out two tangent vectors, tangent vector for line number 1 as well as tangent vector for line number 2. So the tangent vector for line number 1 is given by P L1 dash is equal to P2 minus P1, because the line 1 has 2 points, that is P1 and P2. Okay, so it is given by P L1 dash is equal to matrix ijk into matrix P2 minus P1. So P2 minus P1 for x coordinate is x2 minus x1, for y coordinate is y2 minus y1, and for z coordinate it is z2 minus z1. Here y2 x1 is 5, x2 is 5, x1 is 1, y2 is 6, x2 is 2, sorry, x2 is 5, x1 is 1, y2 is 6, y1 is 2, z2 is 1, and z1 is 7. That is why it is here. Okay. So what will it become? It will become matrix ijk into vertical matrix 4, 4, minus 6. Okay. 4, 4, and minus 6. Okay. So this vertical matrix we can write in equation form also. We have to just multiply this horizontal matrix with this vertical matrix and we will obtain this type of multiplication. So the tangent vector for line number L1 is given by 2 dash for line L1 is equal to 4 I cap 4I plus 4j minus 6k. Okay. Just multiply these two matrices, we will obtain this equation. Now the tangent vector for line number 2 is given by 2 dash line for line number 2 is equal to P4 minus P3 because it is always final minus initial point. Final point minus initial point. That means line number 2 has final point as P4 and initial point as P3. Whereas line number 1 has final point as P2 and initial point as P1. That is why for line number 1 it is P2 minus P1 and for line number 2 it is P4 minus P3. So it is given by matrix ijk into here P4 minus P3 means x4 minus x3, y4 minus y3 and z4 minus z3. Here x4 is 3 and x3 is 7, y4 is 9 and y3 is 3, z4 is 10 and z3 is 4. So it is obtained as matrix ijk into vertical matrix minus 4, 6 and 6. So it can be converted into equation form by just multiplying these two matrices. So it is obtained as P dash for line number 2 is equal to minus 4I plus 6j plus 6k. Okay. Now we have to also find out whether the two lines are parallel or perpendicular to each other. So if the two lines are perpendicular, the dot product of their tangent vector should be equal to 0. This is the required condition to find out whether the two lines are perpendicular or not. Okay, you have to remember it. If if you have to find out whether the two lines are perpendicular, the dot product of their tangent vector should be equal to 0. So let us find out the dot product of the tangent vectors for line number P1 and for line number P2. So P dash for line number 1 dot P dash for line L2, that means 4I plus 4j minus 6k into dot product into minus 4I plus 6j plus 6k. Okay. In this case, multiply the I coefficient with the I coefficient, J coefficient with the J coefficient, and K coefficient with the K coefficient. Okay. So it will become 4 into minus 4 plus 4 into 6 plus minus 6 into 6. Okay. So what will become? So the dot product of the two lines, line L1 and L2 is obtained as minus 28, which is not equal to 0. Therefore, the two lines are, we can say that, we can predict that the two lines are not perpendicular to each other. Okay. Now, we have to also find out whether the two lines are parallel or not. So, the condition is that if the two lines are parallel to each other, the cross product of their tangent vector should be equal to 0. If the dot product of the two lines if the two lines, if the dot product of the tangent vectors of the two lines is obtained as 0, then the two lines are perpendicular to each other. And if the cross product of the two lines are obtained as equal to 0, then if the cross product of the two lines is obtained as, if the tangent vector of the two lines is the cross product of the tangent vector of the two lines is obtained as 0, then the two lines are perpendicular to parallel to each other. then the two lines are parallel to each other. So let us find out the cross product of the two lines. Hello. Sir. हाँ, ठीक है, ठीक है, अभी क्लास में क्लास में तो ठीक है. Now let us find out whether the two lines are parallel to each other or not. So the condition is that when the tangent vector of the two lines are when the cross product of the tangent vectors of the two lines are or is equal to 0, then you can say that the two lines are parallel to each other. Okay. So let us determine the cross product of the two lines P N1 and N2. The cross product is given by matrix IJK. For line number 1, P, the equation of the line obtained is P dash is 4, 4 minus 6. And for line number 2, the P dash for line number 2 is obtained as minus 4, 6 and K. Minus 4, 6 and K. On solving this determinant, you will obtain the value. Suppose that value will be equal to 0. If the value will be equal to 0, then the two lines are parallel to each other. If not, then the two lines are not parallel. Here, the cross product of the two lines and is obtained by 68 plus 4pk. That means it is not equal to 0. Therefore, here the two lines L1 and L2 are not parallel to each other. That means the two lines are neither perpendicular and not parallel. Okay. Also, it is given that we need to find out whether the two lines are perpendicular intersecting lines or not. So, for determining whether the two lines are intersecting or not, let us find out the point of intersection. Okay, if the point of if you find the point of intersection, you can know that whether the two lines are intersecting or not. Okay, so from equations from the previous equations, we know that PL1 is equal to PL2. If the two lines L1 and L2 are intersecting lines, their point of intersection should be equal to should be same. That means point number P1 should be equal to point number P2. Point of intersection of point number P1 should be equal to point of P2. Both lines will intersect at the same point. That means then only we can say that the two lines are intersecting. Okay. So from equation A and B means see. Let's show you. This is equation number A. And similarly, we have obtained the parametric equation for line number 2, that is equation number 2. So the parametric equation of the two lines should be equal to each other. Then only we can say that the two lines are intersecting lines. Okay. So if the two lines are intersecting lines, then the parametric equation of line number 1 and line number 2 should be equal to each other. So the let us equate the parametric equation of the two lines with each other. So here x1 is 1, y1 is 2, and z1 is 7. And the difference between x2 and x1 is 4, y2 and y1 is 4, and z2 and z1 is minus 6. That is why the matrix will be obtained as 1, 2, and 5 plus u into 4, 4, minus 6. Here, the point number coordinates of point number 3 is obtained as x3 as 3, y3 as 7, and z3 as 4. And here, the difference between point x4 and x3 is minus 4, y4 and y3 is 6, and z4 and z3 is z4 minus z3 is 6. So let us take the first terms, then the second term, then the third term, because the first row stands for the first term is for x, the second row is for y, and the third row is for z. Let us equate the first row of both sides for x, second row of both sides for y, and third row of both sides for z. So here 1 plus 4u is equal to 3 minus 4v. Similarly, from second to second row, 2 plus 4u is equal to 7 plus 6v, and from third equal to third row, 7 minus 6u is equal to 4 plus 6v. From these three equations, we can determine the value of u and v. So, from the first equation, 4u, let us take this u on the left side and this one on the right side. 4u plus 4v is equal to 2. Okay. From the second equation, 4u, let us take this 6v to the left side and this to the right side. 4u minus 6v is equal to 7 minus 2, that is equal to 5. And from the last equation, let us take this u on the left side, or let us take this u on the right side and this one on the left side. What will become? 6u plus 6v is equal to 7 minus 4, that is equal to 2. So, I'm solving these two equations, we will get the value of u and v. So, if the two lines L1 and L2 are intersecting, then the equation C, D, and E must satisfy. Okay. So, from equation C and D, let us take 10V is equal to minus 3. On solving the equation C and D, we obtain 10V is equal to minus 3, that is equal to V is equal to minus 0.3. And from equation C, let us substitute the value of V on equation number C. We will obtain 4U minus 4V. V is 0.3. 4U plus 4V. Here, value of V is minus 0.3. That is why 4U minus 4 into 0.3 is equal to 2. Here, so the value of V is obtained as 0.2. Now from equation number E, let us justify LHS and RHS. LHS is equal to 6U plus 6V. Let us substitute the value of U and V. We have to obtain as LHS is 3, which is RHS also in the E equation. So that means here LHS is equal to RHS. So we can say that the equation E satisfies the values obtained from equation C and D. Therefore, we can say that the two lines L1 and L2 are intersecting lines. Okay, students? So in this way, we can determine whether the two lines are intersecting or not. Now, we have determined that the two lines are intersecting lines. So, if the two lines are intersecting, they intersect at a point of intersection. So, we have to determine the point of intersection of the two lines. So, the point of intersection can be obtained by substituting the value of either u is equal to 0.8 in the equation A, or v is equal to minus 0.3 in equation number B. From equation A, we have the equation for parametric equation for line number 1, that is matrix 1 2 7 plus u into 4 4 minus 6 matrix. So we substitute the value of v over here, or substitute the value of v in the parametric equation of line number 2. Then what we now will obtain, the point of intersection of the line. Okay. Yeah. Now substituting the value of u in equation number 1, you will get the point of intersection as u intersection is equal to 4.2, 5.2, 2.2. That means x coordinate of intersection point is 4.2, y coordinate is 5.2, and z coordinate is 2.2. This is the point of intersection of the two lines. Okay, friends. In a similar way, you can solve another problem also. Okay. So let us see this problem also. A line L1 is drawn between 2 points P1 359 and P2 673, and L2 is drawn between points P3 653 and P4 389. Find the parametric equation of the line and the tangent vector. Also determine whether two lines are intersecting. If yes, state the point of intersection. So this is the assignment question. You have to solve this problem by yourself. So I have already discussed one problem of this same type. So following that problem, you can solve this problem also. So this is the assignment question. You can solve this problem. Okay. Then let us end the session of today's class. Thank you very much. Thank you for listening. Let me take the